Let's talk about dividing polynomials by monomials. So for this purpose and for this level of math, anytime you're dividing polynomials, you have to be dividing by a monomial, and the monomial has to be in the denominator. Now I have these set up as fractions, but they could also give you one where it uses the little division sign as well, and you'll see some of those on your practice. So we're going to think of and break this up and to see exactly what's happening. This monomial at the bottom, let's pick a color here. This monomial at the bottom is one term. It has to go into each individual term divided, not just one, but all three. So we're thinking about, we're doing this, 12x to the third divided by 2x plus 4x to the second divided by 2x plus 2x divided by 2x. And now we're going to simplify. So we learned how to do division rules of exponents, and we learned how to divide numbers before. So think about what we did. We looked at just the numbers. 12 divided by 2, we know is 6. When we have the same base as x, we have to the third power and we have to the 1. This division sign just means a big subtraction. So 3 minus 1 gives us x squared. Then we'll do the next piece. 4 divided by 2 is 2. If I have x squared divided by an x, I just have an x left. So 2x can go into 4x squared 2x times. You can think about multiplying these two back right here to get back to where I was, and that's how you know if you're right. And then 2x divided by 2x is 1. So this here would be your final answer. So let's look at option B. Again, this is going into each piece. If you need to set them up individually to see it, please do until you get good at it, and then you'll realize that you can do a lot of it without having to do this. So I'm just going to set them up as two individual problems to show that they're both being divided by the monomial. So then we have 3/12. We can simplify that down to 1/4. We have R2 minus R1, so we just have an R. Now I can write it as 1/4 R, or I could write it as R over 4. That's the same thing, because we understand there's a 1 there. That's the same thing. And then minus 5/12 can't be reduced any further, so that's going to say 5/12. And then we could do R. Now, if you'll notice, these are like terms. So if I have 1/4 R minus 5/12 R, I can actually combine them. So I need to get like terms. These are two fractions, but I have to, when I'm subtracting or combining fractions, they have to have similar denominators. So I'm going to change both of them to have a denominator of 12. So 4 can go into 12 3 times, so 1/4 is the same thing as 3/12 are. 5/12 has already got a denominator of 12. So now I'm going to combine. I have a positive 3/12 and a negative 5/12. They're different signs, so I find the difference. My larger one is the 5/12, so I know my answer is going to be a negative. 5 minus 3 is 2. So 2/12 are, and then again I can further simplify that down to negative 1/6 R. So my final answer would be negative 1/6 R. I want you to try C and D, and then see how you did. All right, for C and D, you have your final answers. 3n plus 5 minus 8 divided by n. Now be careful when you see this last piece. This was taken from negative 24 divided by 3n. We had no n's at the top. So negative 24 divided by 3 is negative 8. Our n, there was nothing to simplify, has to stay on the bottom. So that's how that n stayed on the bottom. And you'd see the same thing in D. All right, we're going to switch our train of thought and go to something to a little bit more advanced, where we're actually having an equation with multiple different variables and we're solving for a certain variable. So this kind of pulls back in beginning of the year literal equations, where you learned how to solve or manipulate an equation for a certain variable. So you've got to do that, but this is then uses this new skill that we have. So we want to get D alone. So D is what we're solving for, so I'm going to highlight D D is what we want to get along. So before I can solve for D, I've got to get everything away from it. So I'm going to add 4R and add 4R. I can't combine 4x and 4R because they're different ones. So now I'm going to rewrite 4x plus 4R equals 2D. These cancel out. Now, I'm closer. I almost have D alone, but I have 2 times D, so I need to divide by 2 on both sides. The 2's cancel out. I'm left with D. And then this is a monomial, because 2 is one single term, and I have to divide into each piece. So 4x divided by 2 gives me 2x, plus 4r divided by 2 gives me 2r. So my final answer would be 2x plus 2r equals D. All right, let's try B. B, we're solving for A. So I'm going to highlight A, and I'm going to get everything I can away from A first. So minus 9, and I'm going to go ahead and take that 3b and, plus 9 and plus 3b, and I'm going to move them over. So plus 9 plus 3b. I can't combine any of those with z, but they cancel here, and I have now on this side z plus 9 plus 3b equals 9a. So I almost have a by itself. I'm going to go ahead and divide by my 9 on both sides. Now remember that 9 goes into each piece. So we have z, make that look like a z instead of a 2, z divided by 9 plus 9 divided by 9 is just 1, plus 3 divided by 9 gives me 1/3 b equals a. This would be your final answer. Solve for A. All right, let's move to a 2-star. We have solving for P. So again, we're going to get P alone, but if you'll notice, we have P's on both sides. So at first, we have to get the P's together. So I'm going to move that first. So minus 2P minus 2P. So I end up with 2P minus S equals 8R. Now, I've got the P's together on one side. I'm going to move my S over. So plus S plus S. So now I have 2P equals 8R plus S. And then to get P alone, I'm going to divide by the coefficient of 2 to every piece. Okay, and you can put it as one line or individually. Obviously, you're doing it individually, so it helps to do that as well. So P equals, well, 8 divided by 2, so 8 R's. If I split it in half, I have 4 R's. And S, remember there's just a 1 there, so I can write that as just plus S squared, or S over 2, not squared, S divided by 2, or I could write it as 1/2 S. That would be the same thing. Okay, all right, let's go to our 3-star, and this is our final one. We're going to be solving for X. Notice that I have X's on both sides again, so I have to get them together. So when I do that, if I move the XG over, I'm going to have nothing on that side. So I'm not going to move the XG over, I'm going to move the 2X over. So minus 2X minus 2X. So I have 4 equals XG minus 2X. Now, a lot of people will be like, well, these aren't like terms, I can't combine them. And you're right, you can't. But notice that they both have a common factor. So we're going to factor it out. So we're going to pull out an X, and we're left with G minus 2. And remember, we're trying to get X alone. So right now, X is being multiplied times the quantity of G minus 2. We're going to divide both sides by G minus 2. That whole little piece, G minus 2. These then cancel out, and you're left with 4 over G minus 2 equals X. You can't simplify any further because notice that G minus 2 is not a monomial. That's a binomial. This is as far as we can go. We can't put that into 4. So this is our final answer.